Hello students, in today's class let us revise probability. So what are all the things we have learnt under this chapter? We know already probability of an event is equal to number of favorable outcomes divided by total number of outcomes. You have to remember this. Probability of any event is equal to number of favorable outcomes divided by total number of outcomes. So to start the chapter, first exercise fully we will be dedicated to find the sample space of the given experiment. A sample space means the total number of outcomes, all the outcomes of the given experiment. Till 10th standard we have seen very simple experiment like tossing a coin, throwing a die, or throwing two dice, or throwing a die two times simultaneously. Likewise very simple experiments we have seen. So in class 11 we had some complicated experiments like two experiments occurring together. Likewise we have seen many things, and in the first exercise fully we have seen how to list out the sample space of the given experiment, because only if we list out the sample space we can pick the elements which is required for our event from the sample space, and then we can find the probability. So writing the sample space plays a vital role in the probability. You have to understand the experiment, what are all the outcomes are going to be, you have to understand it. Then you have to list out the elements of the sample space, right? So when a coin is tossed, we know the sample space is head or tail. When it is tossed two times, it is going to be 2 square, HH, TT, HT or TH. When it is going to be 3 times, it is going to be 2 cube, which is 8. So you have to write all the possibilities. I gave you a clue so that you won't miss out the possibilities. I told for 2 coins it is HH, TT, TH, HT, right? In that 4 outcomes you add H before that. You add H before all those 4 outcomes and then add T before all those 4 outcomes. So 4 plus 4 you will get 8 outcomes, which is going to be the sample space for 3 coins, right? Then a die is thrown 2 times, you know very well. If a die is thrown, then it is going to be 1 to 6. When 2 dice is thrown or a die is thrown 2 times, it is going to be 1, 1, 1, 2, 1, 3, likewise till 6, 6. Totally we will have 36 outcomes, right? Likewise you can give. If you see the fourth one, a coin is tossed and a die is thrown. So how will you give the sample space here? A coin is tossed and a die is thrown. So in the coin, when it is H, in the die it can be 1. When the coin shows H, the die can show 2, H3, H4, H5, H6. So these are all the various possibilities. Similarly, when the coin shows a tail, again there are 6 possibilities. So this is the sample space of the experiment. Likewise, you have to give the sample space. And if you see the next question, it is given a coin is tossed and then a die is rolled only in case a head is shown on the coin. So only when the head is shown, the die is thrown. So what does it mean? If there is a tail, the die is not thrown. So the sample space is going to be H1, H2, H3, H4, H5, H6, and when it turns a T, they are not going to throw a die. So likewise only you have to list out the sample space. Hope you got an idea now. So depending on the question, you have to list out the sample space carefully and properly. Next we learnt about event. Event is the subset of the sample space. Okay, then we have learnt that various types of events like impossible event and sure events. Impossible event means the event cannot occur. Probability of an impossible event is always 0. Probability of sure event is 1. Sure event means the entire sample space will become the event there. Okay, then we have seen what is meant by simple event. Simple event means only one outcome will be there in the event. So that is called a simple event. Okay, if the sample space is HH, HT, TH and TT, then every simple event has one event. If there is only one element in the event, then such a kind of event is called a simple event. Compound event. Compound event means more than one sample point. Okay, if it has more than one sample point, we will call it as a compound event. Then we have seen what is meant by complementary of an event. Complementary event means not A. Complementary event to A is not A, right? If an event, for example, if event A is getting ahead, then complementary of that event is event of not getting head, not getting head. How to find that not A? 1 minus P of A. Okay, A complement is nothing but 1 minus P of A. Hope you remember all these things. Event A or B. A or B means union. A union B. A or B means A union B. A and B means intersection. A and B means intersection. Both A and B means A intersection B. A but not B means A minus B. Difference. A but not B means A minus B. That can also be written as A intersection B complement, not B. So B dash, A but not B. So A, B complement, and you have to find the intersection. Right? A minus B is equal to A intersection B dash. Right? So these are the 4 things you should remember. A or B means union. A and B means intersection. A but not B means A minus B or A intersection B dash. Right? Then we have seen mutually exclusive events. Mutually exclusive events means the 2 events which don't have any common elements. The 2 sets which are disjoint are called mutually exclusive. So when we talk about events, the 2 events which do not have any elements in common, we will call it as mutually exclusive events. Then exhaustive events means the events which you make union, you will get the entire sample space. Okay. If you find union for all the exhaustive events, then you should get the entire sample space. Then that is called exhaustive events. So likewise, these kinds of questions you may expect in 1 mark. They may ask which of the following are exhaustive events. Likewise, or give some examples of a mutually exclusive event. So you should able to give. Based on this only, we have solved our next exercise. It's very simple. Again, they will give you a question and you have to give the events in the description, roster form, and then they'll ask you to find union intersection. It's a very basic question. Again, we didn't get into probability yet. Okay, so it's like an intro. See here, a die is thrown. Describe the following events. A number less than 7. So a number less than 7 means 1 to 6 elements will come in A. Since a die is thrown, the sample space is going to be 1 to 6. The event is number less than 7. Number less than 7 means 1 to 6 numbers. Then you have to list out multiples of 3 in C, even number greater than 4. Likewise, after listing out, you have to find union. Union means you have to write all the elements of A as well as the elements of B, and you should not repeat the elements. Intersection means common elements. Minus means what will you do? A minus C means you have to leave the common elements and you have to write the remaining elements of the first set. Leave the common elements and you have to write the remaining elements of the first set. Then complement means you have to write the remaining elements which is not existing in that event. F complement means you have to write the remaining elements in the sample space which is not in F. Okay, that is complement. When they ask you to find E intersection F complement, you have to write what is E, you have to find what is F complement, then you have to find the intersection. Alright, hope you got it, and you should know the meaning for these also. If they ask you to find not B, which means B complement. A or B means A union B. A and B means A intersection B. A but not C means A intersection C complement, or else A minus C. Likewise, only if you know the meaning, you can solve a problem of this kind. Okay. Next only we have seen the axiomatic approach to probability. We know probability of any event should be greater than or equal to 0. Probability of sample space, which means a sure event, is always 1. And if E and F are mutually exclusive events, then probability of E union F is P of E plus P of F. If they are not mutually exclusive means they don't have any intersection. The intersection part is empty. If they have any intersection, you have to subtract that intersection. Okay, hope you remember all these things. See, probability of A union B is P of A plus P of B minus P of A intersection B. If the intersection is empty, if they are mutually exclusive events, then you will have only sum of these two probabilities. And probability of A complement is 1 minus P of A. Right? That's it. Using this only, we have solved our next exercise. Let us see few examples now. So if you take this example, one card is drawn from a well shuffled deck of 52 cards. If each outcome is equally likely, calculate the probability that the card will be a diamond, not an ace, a black, not a diamond, not a black card. So in general, to find the probability of an event, the formula is number of favorable outcomes divided by total number of outcomes. This is the basic thing you have to remember. Hope you know the different types of cards, right? How many diamond cards will be there? 13. So probability of that event is going to be 13 divided by 52. Then what is the probability that it is not an ace? So when we have not an event, we can find for that event and then we can subtract from 1. That will give you not an event. So let us find what is the probability to get a ace card. So to get a ace card, how many ace card will be there? 4 ace cards. So 4 divided by 52 is the probability of getting an ace card. So not an ace card is 1 minus probability of that. So you have to subtract, right? The next question is getting a black card. How many black cards will be there? 26. So that you can do it directly. Next is a card drawn. What is the fourth question? Not a diamond card. So the same way, first we can find it for diamond card. And then we can subtract from 1. Diamond card, how many will be there? 13. 13 divided by 52. Right? Which is nothing but 1 by 4. And then now last question is not a black card. Not a black card also you can do it in a same way. We can find for black card and then we can subtract from 1. That will give you not a black card. Right? Hope you got it. Hope you people are recalling the things. This kind of problem, this is another type of question where they will give you the probability directly. Two students, Anil and Ashima, appeared in an examination. The probability, Anil will qualify the examination as 0.05, Ashima will qualify as 0.0. So the probability answer is given. Probability that both will qualify means intersection is given. They asked you to find the probability that both will not qualify. Both will not qualify means what? Anil also not qualify, Ashima also not qualify. So A dash, if you take E and F, E dash intersection F dash. Both not qualify. Not means complement, both means intersection. So we have to find E dash intersection F dash. Here and all you have to use De Morgan's law. How you will use De Morgan's law? E dash intersection F dash is nothing but E union F the whole dash. Right? So what is probability of E union F? P of E plus P of F minus P of E intersection F. So we will get what is probability of E union F. Right? So probability of E union F the whole dash is 1 minus probability of E union F. So if you substitute, you can get the answer. Next is at least one of them will not qualify. At least one of them will not qualify is nothing but 1 minus both of them will qualify. Right? At least one of them will not qualify. What is the quite opposite of that? Both of them will qualify. Both of them will qualify means what does it mean? Both of them intersection. Okay? P of E intersection F. So that value you have to subtract. So only if you understand the meaning, you can apply the values directly. Okay. Next question, only one of them will qualify. Only one of them will qualify means what is a formula here? Probability of E intersection F dash or E dash intersection F. Okay. Both, at least only one of them will qualify. Either E will qualify or F will qualify. If E qualifies, F will be complement. If F qualifies, E will be complement. Both will occur. So union. So it is nothing but probability of E intersection F complement plus probability of E dash intersection F, because these two are mutually exclusive events. Then how to write this intersection? P of E intersection F dash is nothing but P of E minus P of E intersection F. Hope you remember we read all these kinds of formulae in our set theory. sets chapter, right? First chapter. Then E dash intersection F is probability of F minus probability of E intersection F. If you substitute the values, you can get the answer, right? Another question is a type where we used the combination formula. This type of problem also you can expect. A committee of 2 persons is selected from 2 men and 2 women. What is the probability the committee will have no man, 1 man and 2 men? So the total number of persons is from 2 men and 2 women, it is going to be 4. Out of 4 persons, 2 can be selected. A committee of 2 persons is selected from 2 men and 2 women. So out of 4, 2 is selected. So what is the total number of possibilities there? 4C2. This is sample space, N of S. Now our question is no man. The committee will have no man, which means both the 2 committee persons should be selected from 2 women. So the favorable outcome is 2C2 divided by total number of outcome is 4C2. Next question is only 1 man. So out of 2 persons, 2 committee persons, 1 should be selected from men and 1 should be selected from women. Right? So 2C1 into 2C1. Hope you understood. Next question is 2 men. Both of them should be men. So it is going to be 2C2 divided by 4C2. So like this type of combination questions also you can expect. So we have seen 3 different types of questions. One is direct question. Another one is the probabilities will be given. Another one is based on combinations. Okay. Hope I have recalled all the different types of problems where we have done in the chapter probability. So I want you to do these problems as practice. And if you have doubts, you can ask me, and even you can go through the videos which we have done in the chapter probability. All right. Thank you, students.